In this video, we're going to have a look at sequences and how we define a recursive rule for them. So in mathematics, a sequence is essentially a string of objects, and in our case, some numbers that follow a particular pattern or rule. When we look at a sequence of numbers, we're going to call each individual element a term. So let's start by considering our first example. We have a sequence of numbers 3, 7, 11, 15 and 19, and this pattern will continue. What we want to first have a look at is if we can identify what's happening as we get from one term to the other. So from 3 to 7, I can see that, there's a difference of 4. From 7 to 11, there's a difference of 4, and 11 to 15, okay, I can see a pattern. It seems that as we go from one term to the next term, I'm adding 4. So in our case, if we look here, we can call our first term T1. So we're going to use this notation of a capital T for the term, and we're going to put a 1 if it's term 1. If it's term 2, we're going to put a capital T and then a little subscript of a 2 for term 2, and then we would call term 3 to be 11. So as I'm going from term 1 to term 2, I seem to be adding 4. To get term 3, I need to add 4 to the previous term. To get to term 4, I must add 4 to the previous term. And to get to term 5, I'm adding 4 to the previous term. So my pattern here is adding 4 to the previous term. We're going to think about it as how do we continue this sequence using that previous term. So we've got a notation here of how we can write when we're talking about each term. So a capital T for the term and a little number representing each term. So if I was writing term 5, I would write T5 equals 19. So what I'm thinking to myself was, how do I get term 6? Well, I'm going to have to use the previous term, 19, and then add 4. And that will give me 23 as my next term. So if I asked you what is the value of term 8, well, I would just keep continuing on my sequence here, and I would say, well, I've got 23 for term 6, term 7 will be 27, so term 8 will be 31. For terms 2 plus terms 3, so I'm going to say, well, term 2 is worth 7 and term 3 is worth 11, so adding terms 2 and 3 together, I get 18. In my next notation, I've got 3 lots of term 4. So this is 3 lots of, not 4, but term 4, if we have a look, was represented by 15. So it would be 3 lots of term 4, its value, which is 15, and I would get 45. And here a bit of BIMDAS, 2 lots of term 4, which is 15. Take term 2, which we know was 7. So it's 2 lots of 8, and that will give me a value of 16. So we can see very clearly that this notation here tells me what term I'm talking about, but its value is the actual number. What I'd like to do now is see if we can define what we call a recursive rule. And this rule helps us find the very next term of a sequence, knowing the previous term. Basically, it generalizes how a sequence is recurring or repeating its pattern. So let's consider our first example again, which was 3, 7, 11, 15, 19, and continuing. Now we know that we had a pattern of adding 4 to the previous term. So basically we know our pattern was plus 4. So I'm going to call this the difference pattern, and it reminds me very much of a linear pattern, the difference. And I'm going to give it the letter D just to define it a little bit better. And the nice thing about this pattern is we call it an arithmetic pattern or an arithmetic sequence, because we seem to be adding something on, whether it's adding 4 each time or taking 7 each time. So let's go back and consider how we formed each term. So term 1 was 3, and that was given to us. But we found that to find term 2, we needed to get term 1 and add 4 to it, and that gave us our 7. To find term 3, we needed to take term 2 and then keep adding 4, and that gave us our term 3 of 11. So when we did term 4, we had to take term 3 and add 4, and that's how we got our 15. So what we want to think about is, well, what happens if I wanted to find term 10? Well, it seems I'd have to know the term before. So I would need to know term 9 so I could add 4 to it. If I wanted to find term 20, I must know term 19 so I can add that difference of 4 to get term 20. So if we think about this in a generalized way, if we consider saying if I want to find any term, term 10, or let's have a look, consider talking about term 4, for example. If I was wanting to find term 4, I must know term 3, which is the term directly before it. So if I call the term Tn, the term directly before it would be Tn take 1. And I must then be able to add 4 to it. And what I formed is what we call a recursive rule. But imagine that I took away the sequence and all the information about the numbers, the first 4 or 5 numbers, and I just gave you this recursive rule. You would say, well, that's great, but I know I have to add 4 to every term to get the next term. However, where does my sequence start? And this is a really important point about a recursive rule. You must always state the first term so your sequence has a starting point. So this is a really, really important point. So what we've created here for our first example of an arithmetic sequence is a recursive rule to represent or be able to show what this sequence looks like. So with any arithmetic sequence, we could write our rule to say to find a term, you must know the previous term and you must add on the difference when you know term 1. And we actually call term 1 the letter A. Sometimes we use the notation where we start with Tn plus 1. So if I'm talking about term 4, the only value I would put in here for n is 3, so 3 plus 1 is 4, which means the previous term would just be called Tn, and then I would have to add my difference on knowing what my first term is. So sometimes we can note that depending on the notation that's used, we might change the way the notation that we use to write a recursive rule. So let's take a look at one more example. We've got the sequence 2, 6, 18, 54, and 162. And it seems those numbers are getting big quite quickly. So I'm going to call the first one T1, term 1, or I can give it the letter A. I've got term 2, term 3, term 4, and term 5. Looking at this pattern, I can clearly see it's not arithmetic. We're not adding on something to get to the next term, and I think that's constant. But so I'm thinking maybe are we multiplying by something? Well, 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. And very quickly I can see that we have this sequence where we're multiplying to get to the very next term. In fact, we call this a geometric sequence, because we seem to have this multiplying number. This does remind me a bit of exponentials as well. So we've got a constant number that we're multiplying by to get to the next term. So we're multiplying by 3 to the previous term is my pattern. So I'm going to call my term 1 or my A 2, but this time I don't have D, a difference pattern. I could probably call this like a multiplying factor or a common ratio. So let's use R as the value that we're multiplying by, and it's getting large, so it's going to be above 1. So I'm thinking, how do I write now a recursive rule? Well, to get from term 1, which is 2, to get to term 2, I need to use the previous term times 3. To get to term 3, I need to use the previous term, which is 6, and times it by 3. So if I want to get to term 10, I'm going to have to know term 9 that I'm going to multiply by 3. So using a recursive rule, to get to the nth term, I need to know the previous term, so that for n it would be n take 1, and then I'd need to multiply it by 3. But I must state what my first term is. I could neaten this up a bit because I am a mathematician and I know that I don't have to put a times, and I like to put my coefficients out the front. And so that's a much neater recursive rule for this geometric sequence. Again, I could slightly change my notation to have Tn plus 1 out the front, which means if I'm finding that term, the previous term would just be Tn, where my first term is 2. And these represent exactly the same thing. This rule will allow me to start from the number 2 and keep multiplying to write my successive terms of this sequence. So now it's your turn. Have a go at these 3 questions, being able to just state some terms, write a recursive rule, and also use a recursive rule to find the terms of a sequence.